Let's have a look at how we can play with trig identities to answer questions like these. Now, in all of these questions, we have to find a nice simple trig ratio in terms of theta. And what we've been given is negative theta, all kinds of other things in brackets to play with. So to be able to do this, it's good to be able to understand everything that we have here. Perhaps we're not going to need the Pythagorean identities, but I've put them up there just so that we've got a complete list of all our trig identities. We need to know how to use all stations to central, which means that all trig identities are positive in the first quadrant, only sine and its reciprocal in the second, tan and its reciprocal in the third, and only cos and its reciprocal in the fourth. Now, what are the reciprocal ratios? That's cosec, sec and cot. So we've learned the definitions of those. And it's handy to know also, mostly you want to go from this to this or back from there to there. It's handy though to also know that, say, these two could swap. So sine theta, for example, is 1 over cosec theta. That's handy to know because occasionally you'll see it round that other way and it's good to know it backwards. All right, the ratio identities are important. If we know that tan and cot are the reciprocal of each other, you can write it like this, but what it also means is something's reciprocal is like a fraction that's been flipped upside down. So if we know that tan theta is sine theta over cos theta, then it makes sense that cot theta is the flip of that fraction, which is cos theta over sine theta. All right, the complementary ones. We need to know these for some of these questions, so let's focus in here. Now, these ones are actually quite lovely in the naming, which reminds you, complementary means adds up to 90, okay? Now, when you write the three-letter abbreviation of these, it's hard to see what's going on, but if you think of the full word, sine goes with cosine, tangent goes with cotangent, secant goes with cosecant. See how those are actually really easy to remember. The co means if you go together, they'll add up to 90. Now, how do you use those? Well, it's quite simple. Remember, if you've got something like, say, sine of 20 degrees, you know that's the same as the cosine of 70, because 20 and 70 add up to 90. So you can flip and change between either of these pairs whenever you like to get to where you need to be. Okay, something that might be simpler. So, for example, if you know, if you want to change something from sec to cosec, you might have, say, the sec of 10 degrees. That will be the same as the cosec of 80, because 10 and 80 add up to 90. So these are handy because if you've got one of these ones, you can just convert it to those, okay? Now, there aren't any quite that straightforward here, but if we had one, let's do it like an opening example, nice and easy. If we had something like cot of 90 minus theta, and we were asked to find what it is in terms of theta, we'd say, well, that's easy. You just change from cotangent to tangent, which is tan, and that's tan of theta. Done. Really simple. Okay, so those ones are good to know. All right, what else do we need to know? Well, down here, we've got a drawing that's really important. We've got theta here, and I've reflected it with symmetry across the x-axis so that it goes from here and bounces down there. And I've also reflected that across the y-axis, so I've got the same angle here and here. Now remember, we need to know how to name this ray here, okay? And it's got a bunch of names. We could start from here, the 0, and name it going upwards in a positive direction and call it theta. That's its most basic name, right? But don't forget we can do laps of this and get 360 plus theta. We can do another lap and add 360 and we'll have 720 plus theta. They're all the exact same ray. So if we know what the sine of theta is, we also know what the sine of 360 degrees plus theta is. It's going to be the exact same answer. They're interchangeable because it's the same place on the coordinate plane, isn't it? Now I'm going positive and I've put dot, dot, dot. I could keep adding 360 here, but it also makes sense I could go around the other way, couldn't I? I could go backwards. I could take 360 off each of these answers. So the next one going back this way, the next smallest one, well, if I take 360 away, you'd say theta minus 360, or you could write it as minus 360 plus theta. Going back the other way, minus 720 plus theta, dot, dot, dot. Okay, so understand that we can do laps this way or laps that way, as long as we're ending up in the same place. the same answer, okay? Now, we've got one like that over here, so let's do that one first. Cot of 360 plus theta, well, that's going to be exactly the same as the cot of theta, because 360 plus theta just means you've gone round and then gone a little bit more. It's the same as just doing that theta in the first place. So that one's easy. Cot theta, done. Okay, now we don't have to think about whether it would be negative or positive or all stations to central or anything like that, because this is in the first quadrant and so is this. So if it's positive or negative there, it's exactly the same there. So no need to even think about the sign. All right, let's think about this ray over here. Now the most obvious name for it would be 180 minus theta, because you get there by going around to the 180 and then taking theta off, don't you? So we've got to know that that's 180 minus theta, okay? Now, when we want to find the sine or the cos or the tan or any of these other inverse ratios of 180 minus theta, what we've learned is that it's exactly the same as finding the sine, cos or tan of theta, except you've got to think about the sine. And by that I don't mean S-I-N-E, I mean S-I-G-N. Only the sine ratio will be positive over there. Otherwise it will be the exact same number, but if it's tan or cos, or any of the reciprocals of tan and cos, like sec and cot, and it's over here, then it's going to be negative, okay? So let's do this one straight away, because it's got a 180 minus theta there. Now, what we've learned is that tan of 180 minus theta, or anything of 180 minus theta, is exactly the same as the tan of theta, except we have to think about whether it's positive or negative when it's in that second quadrant. And we're doing tan. And tan is negative over there. So it's the same as the negative version of tan theta. Okay? All right, so that's that one. Now, just as we could here go round and add 360 or take away 360, we can do the exact same here. So if this ray, or this position, is called 180 minus theta, you could also add 360 to that and say it's 540 minus theta. You could add another 360 and another, going on forever. And you could also take 360 away, couldn't you? And say this is minus 180 minus theta. Okay, I've just taken 360 off 180 to get minus 180. And that would go on and on forever as well. So if you get an answer, a question like this over here, 540 minus theta, just take 360 off that to make it a little bit nicer looking and simpler, and it'll be exactly the same. Just like this one was the same as if we just took 360 off it.